Do you guys have any questions? Which one should we go over? Let's do a few of these.
All of them.
Let's do the front first.
All of one. Five.
Yeah, 6 is a good one.
Five.
Alright. So, you'll notice on these problems that I left off some numbers. So very similar to when you guys are graphing straight lines, if you had to do like y equals 2x, right? And you're looking for the slope and y-intercept, you had to know that's y equals 2x plus 0. That way you know to start at 0 and go up 2 over 1 and so on to get your straight line. So sometimes there's those numbers that are missing. Same thing here. So if there's no number being added or subtracted at the end, okay, we have to know well, that means it's 0. Okay? So that puts our vertex at 6, 0. So missing numbers, if you're adding, subtracting, are always 0. Missing numbers, if it's multiplying, is always 1. So like if there's no number, nothing in front of the parentheses, I know that the a value is 1. Alright, so we know it's at 6, 0. And is it opening up or opening down? Down, right? It's negative. So I know it's going down this way. And if I plug in 0, that's our normal routine, plug in 0, I get 0 minus 6 is negative 6. Negative 6 squared is 36. And then times negative 1, negative 36. So negative 36 is like, way, way down here, so we can't use that. So let's just plug in a number next to the vertex. That's your next backup plan. If 0 doesn't work, start picking some points close to the vertex. So I wouldn't want to plug in 1 or 2, even though those are nice numbers. Those are going to be really small too and not going to fit. I need something that's going to be bigger than negative 8. So the closer to the vertex you pick, the better off. So let's plug in, let's say, this number, which is 5. And see what we get. And that's it, yeah. I don't have to. Good. So we'll have this equals negative 1. So I plugged in 5 and I got negative 1. So we get 5, negative 1, and of course I get another one on the other side for free. The complement. And then from there, draw a parabola. So most everybody is doing very well on the parabolas now. So curved at the top, and it goes outward ever so slightly. Never straight up and down, never a point at the vertex. Alright. Good. That's a good graphing example. On the backhand side was just about, well, get it into this format so we can graph it and also solve it today. So any requests 1 through 12? Actually 1 through 10, any of those? So I mean 7 through 10? Okay. 11 through 15? 11? Alright. So from 10 to 11, the difference is there's now numbers in front on all of these. So we had one little extra step when we had a 2, a negative 2, a negative 10, a negative 4, a 2. Whenever there's a number in front, we're going to do a GCF, take that out, which means divide. So negative 2x squared divided by 2 is x squared. 12x divided by 2 is 6x. 10 divided by 2 is 5. And then we'll do the same normal steps. Just leave that 2 out in front. Okay. Go ahead and complete this square. Half of 6 is 3. 3 squared is 9. Five minus 9, negative 4. Or you can think 9 minus what is equal to 5, same thing. Now I'm going to factor just these three. Bring down the minus 4. This factors 2. Half of 6 is positive 3. So I got x plus 3 squared. And vertex is at negative 3 comma negative 4. So that's an example of having a GCF, factoring it out, and doing the same steps. Is this correct, actually? Now think about it. Whoa. Yep, sorry. I did just catch myself. Yeah, got to distribute that 2 back in. So one more step. Minus 8. So yeah, one little thing wrong, and now our whole graph will be at the wrong place because of one step. So you can see, the real, this is nice, good example of algebra. What's the arithmetic we're doing here? We had to divide by 2 3 times. You learned how to divide by 2 in the 4th grade, maybe? You had to take half of 6. Again, 4th grade, maybe 3rd grade. Then you had to do 3 times 3 and get 9. And then you had to do 5 minus 9. So the arithmetic we're doing is very, very basic. But what makes it algebra is that you have to know where everything goes. It's more about putting things in the right place and being organized, not can you add, subtract, multiply, divide. So please keep your work organized so you can follow it, and then you'll do maybe like I just did, catch yourself when you notice if it's organized and you do it the same way every time, you catch yourself and you can maybe fix something before it becomes a problem. Alright, good. Lastly, let's look at 16, 17, really just 16 and 18 and like those. So some people are asking like, well, there's no minus or plus, it's just x squared. So it's the counterpart to what we did up here. So when there was no number, I put in the 0, right? Same thing here, it's just on the x value. There's no add or subtract on the x, so it's the same thing as this. So my vertex is at 0, 6. So you can be missing the plus the c value on the end, or if it's just a regular x squared, that's the same as x minus 0. So you know your x coordinate is 0. Same thing on 18. It's the same as x minus 0 squared minus 8. So we simply have 0, negative 8. Yeah, when there's no b, it's a lot easier to get vertex form, a lot easier to solve even. If you think about it, if you tried to complete the square, okay, the number inside would technically be 0x. So you take half of 0, square it, and it doesn't change the equation at all because it's 0. So you could go through all the steps of completing the square, but if b is 0, it doesn't really change anything. Let's see here. And down here, just a little review of solving. Add 3 to both sides. X squared equals 1. So x equals 1 and x equals negative 1. Just trying to get the variable by itself. Add 10 to both sides. K squared equals 64. Take the square root of both sides. And you can tell I gave you some nice numbers, right? The square roots are coming out to 1, 64. You'll subtract 5 here and get 100. So I gave you some nice numbers, but they don't have to be. I mean, they could be any number and it'll still work. Recall here, if you get 0, there's only one answer. There's only one number squared that equals 0, and that's 0, unlike some of the others. 8 squared is 64, but so is negative 8 squared. So that's why we have two answers here. Okay, so I'm going to let you guys keep that, finish it up, make it pretty and perfect. And let me introduce you to what we're doing today, which won't require anything new. Okay, so just handed this out from the folder. We're going to take this and what we've been doing and wrap it all together and summarize it into one problem. So all these different skills we've been doing since last week really add up to just doing one thing, is graphing this parabola. Okay, so let's show you what I mean. We're going to be solving, which means that's the last 4 problems we just did where you get 2 answers most of the time. That's the solving. Okay, but we're also going to be sketching a graph. Now it is going to be a sketch, so you're just going to draw the graph and roughly put some points on there, and I'll show you what I mean. So solve by completing the square. Start off by doing the same thing you've always done. Here we go. Okay, n squared. Okay, figure out what your c value should be, your perfect square value. So we got half of -2 is -1, -1 squared, +1, okay. And then -15 minus 1 is -16. Or just do 1, what do I got to do to get to -15? I got to do 1 minus 16 to get to -15, same thing. Alright, let's go ahead and just factor that. So we'll have n, half of -2 is -1 squared, and bring down the -16. Okay. So here's what we know. My vertex is where? Okay. Yeah, my vertex is at 1, -16. So you're going to sketch that. And it is a sketch. It's not going to be perfect. You're not going to count squares or anything, but you know that +1 is to the right and -16 will be down. So roughly. Okay. Now we're also going to solve it. Okay, what does it mean to solve? So you notice that these are equal to 0. Instead of y, equals to y, it's equal to 0, which means we want to know on the y-axis, where is this 0? Okay, so in other words, we're finding the x-intercepts. Where does this parabola cross? We know this does parabola go up or down, by the way? Up, yeah. Oops. So we know it goes like this. And we know it's going to be symmetrical, so it's going to look something like that. I want to find out what these are. That's what the solving will give us. So when we set it equal to 0, we're saying, where does it cross right here? Because this is where y equals 0. These are +1, +2, +3, and negative, negative, negative. So 0 is right in the middle. I want to know. Okay? And we're going to tie in exactly what we just did. Let's go ahead and solve this. I'm going to add 16 to both sides. So now it equals 16. And you guys know how to do the rest already. What's next? Square root both sides. Let's take the square root of both sides. N minus 1 equals, actually, you got to be careful here. N minus 1 equals 4. Alright, so n equals 5. So what does that value tell us? Okay, where's 5 on the graph? Yeah, that's this one right here. So this is x5. Are we finished? What about this other one over here? What's that answer? Alright, so remember, when we do the square root, you get 2 answers. So we also have n minus 1 equals -4. Because 4 squared is 16, and -4 times -4 is also 16. So remember, you get 2. We get 2 of them, just like we did. Let me pull it back up. And that's not it. This one? Yeah. Just like we did right here. Remember, we got 2 answers. So we get 1 plus, 1 minus It's just that there's more stuff on the left and the right hand side, but we still the same idea. I know, showing you we've already done this. Okay, so we get an answer of n equals -3. So this is -3 over here. So this is the sketch I want to see for part B on all your problems on this side. Is the vertex and then the two intercepts, or maybe sometimes there's one intercept. It's possible to have no intercepts, but I think all of these have two intercepts, just for starting off. So this is what we already been doing. This we did last week. The graphing we've been doing for 2 weeks. So it's just tying everything we've already done together. Nothing new. It's all the same. All the same. But we have to know what these answers mean now. That's the biggest difference. We can't just get an answer, oh, here's the vertex form, and okay, I'm done. It's okay, let's see what that means on the graph. Here's the two answers, right? Well, what do those mean on the graph? Okay, those represent intercepts. If this was an object going, up in the air and coming back down, the x-intercepts are where it takes off and lands, and the vertex is like how high it goes up in the air and coming down. So depending on your problem, sometimes you want to know where something's landing, that's finding x-intercepts. If you want to know how high something got in the air, that's the vertex. So these values stand for something and actually mean something more. All right. Let's have you want to do another one here? Yeah, let's try number 2. And I think, well, actually, no. Let's try number 3. Yeah, let's do 3. All right, so you guys started off. I'm sure you know how to do the first part by now. What do I need to complete this? Half of 6 is 3. 3 squared is 9. Okay. And then 9 minus what is -25? 9 minus 36 is -25. You can also do -25 minus 9, which is -36. Okay, and that's just equal to 0. Whenever you see equal to 0, that means you're solving for your x-intercepts. You're starting and landing. All right, so let's factor the first 3 terms. What does that equal? A half of 6 is 3. Bring down the -36. Okay. I can start my sketch. So vertex is, yeah, right here. -3, -36. And you can see how important a negative is. If I said, oh, it's at 3, 3 -36, it's on the opposite side of the graph. It's very different. So one little line on paper doesn't look that different, but on a graph it's completely opposite. All right, and now let's solve. So add 36 to both sides. Okay, so now this will be equal to 36 by adding 36 to both sides. So that a plus 3 squared equals 36. Square root both sides. So careful, get your 2 equations. A plus 3 equals 36. No, sorry. Equals 6. And a plus 3 equals -6. Okay, so we know it's going this way and it's going this way. There's 2 answers I'm looking for. Alright, so we have a is equal to 3. Alright, so there's 1, 3. And then A is also equal to -9. Alright. Again, nothing really new. I mean, the only thing really new is that we're drawing a sloppy graph. We don't have a nice one. But completing the square we've done, taking the square root of both sides we've done, and now, big picture, we're graphing all these answers so we know what they represent. Alright. Just make sure when you get down to here, you do the GCF first. So start off by taking out a GCF. Number 8, leave alone for now. We'll do that together tomorrow. The difference is here is that when you divide by 2 everywhere, you actually get, well, since this is an odd number, we'll get a fraction, and it's the same exact steps. We're still going to take half of 10, square it, but sometimes, since this is 5.5, some people get weird, so I don't want you panicking about that. We'll just do it together. So it's okay. This 11 over 2 just means 5.5, so it'll just come out to some decimals. So our vertex will be at a decimal and whatnot. That's okay. Alright, so that's the front. Let's shoot over to the back. This is going to be more of a review, but again, we're tying a lot of things together. Solve by factoring, still equal to 0. So instead of completing the square, right, taking half of 11 and doing all that, we could complete the square to solve, but we're going to do factoring instead. So what 2 numbers multiply to 24 and add to 11? What do you get? 8 and 3. Or 3 and 8, right? Just factoring. So we're going to get x plus 8 equals 0, and x plus 3 equals 0. So x equals -8, x equals -3. Now, what do these mean graphically? Yeah, those are x-intercepts as well. So I know for this parabola, it's going to go through -3 and -8. Here's the thing with factoring. We don't know where the vertex is. I do know the axis of symmetry is right in the middle, right? The very middle of these 2 points. Okay. We don't, yeah, we know it's in the exact middle, but we don't know if the vertex is way down here or up here. I do know it's opening upward because this is positive, but that's the downside. So I'm just going to estimate. I'm just going to estimate that way. I don't know where the vertex is, though. So here's the thing. When do you want to use factoring? When do you want to use completing the square? If you don't care where the vertex is, factoring, you can see this right here. That is a lot less work than all that, right? But they give us the same exact value. If I complete the square, I'd still get -3 and -8. Yeah. Actually, watch me on this one, on number 11. What if I complete the square here? What would I get? Half of -2 is -1. Square that, you get +1. So this is already a perfect square. right? So I'd get r minus 1 squared equals 0. Take the square root of both sides. You get r minus 1 equals 0. Add 1 to both sides. R equals 1. What if I did it by factoring? What are the two numbers that work? Okay, what multiplies to positive 1 and adds to negative 2? Negative 1 and negative 1. Now, isn't that the exact same thing as r minus 1 squared? Yeah, you get the same answer whether I do completing the square. Right? Both of them you get r minus 1. So it's a single problem that we have two methods of solving, just depending on what we're given. So the biggest thing that's going to be you're going to want to develop is, well, when do I want to use which method? And it all revolves around if you care about the vertex or not. So on the back, we're just practicing. You don't have to do both of them. I just want you to do just the factoring. But know that you get the answer for both. Now, what does it mean when you get one answer? I only got r equals 1. What does that mean? What does that look like? Yeah, so here's, all right, my x-intercept is 1, right? I only got one answer. It's opening upwards, so I know this. That 1, at 1 comma 0, is also my vertex. So I do know the vertex on this one is 1 comma 0, simply because I have one answer. Whenever you get one answer, that one answer is also your vertex. Alright. Anything else? Let's see here. Let's go down a little bit. Don't forget about GCFs. Notice this has no C value. Just factor out an n. 7n minus 4. So I get n equals 0. 7n minus 4 equals 0. So I got one answer, n equals 0. Solve this other one. Add 4 to both sides. 7n equals 4. Divide by 7 on both sides. N equals 4/7. So I got my 2 x-intercepts. So can we have fractions? Can we have decimals? Absolutely. So yeah, let's say this is 1 right here. Just 1. So I have 1 x-intercept right here and 4/7. So if I cut this up into 7 parts, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. There's my other. And I know it opens up, so it's going to look something like this with that vertex right down the middle at 2/7. That's the middle of 0 and 4/7 is 2/7. But I do not know exactly where this vertex is. Yeah, good. Let me think here. Is there any others? Yeah, rest is just straight factoring. And I'll leave it at that. All right, you guys go ahead and get a good start on number 2. I'll come around and check it just to make sure. Work with each other if you need to, but remember, it's just everything we've already done put together all in one problem.